already we have discussed two type of classification, that is first two, and in this video we will look into these two types of classification. So let's get started. Third type of classification is even and odd signal. What are even signal? Which exhibit symmetry in the time domain. This means they are symmetrical in some sense. What kind of symmetry they show? Symmetry about the vertical axis. Now what does this mean? Like if I take an example of suppose cos wave x of t and t, how a cos wave is being shown? This way, right? And on the other side again this way. This is the cos wave. This is pi by 2. This is pi. And here this is 2 pi. Similarly, this point minus pi by 2. This point is minus pi. And this point is minus 2 pi. So can you see that this cosine signal is symmetrical about this vertical axis x of t. The value it shows as pi by 2 is same as the value it shows at minus pi by 2. Similarly, the value at pi and minus pi is also same. So this type of signal are mirror image of each other. Here we can see along the vertical axis, they are mirror image of each other. So any such signal which is symmetrical about its vertical axis is an even signal. And how can it be shown mathematically? Like this. X of t is x of minus t. How you can prove this? That you, as I told you, that x of pi is equal to x of minus pi. At x equal to pi, value is minus 1. Similarly, at t equal to minus pi, value is again minus 1. Which is same. Again, for x equal to pi by 2, its value is same as x equal to minus pi by 2. So these signals are even type of signals. Now what are odd signals? Which shows antisymmetry or which are identical to its negative. For this we need to take an example of sine wave. This is sine wave on positive time axis, a sine wave on negative time axis. This is 0, pi, 2 pi, minus pi, minus 2 pi. So can you see that it is symmetrical about origin? You can also say that these odd signals are symmetrical about origin or identical to its negative, means the portion which is above on the positive side of xt, it has the similar portion on the negative side of xt. So that's why these are symmetrical about its origin. These are the following conditions an odd signal must satisfy. As you see that this is pi by 2, which has the value of 1. This point is minus pi by 2 and its value here is minus 1. So from here you can see that at x equal to pi by 2, the value is 1. But what is the value at x equal to minus pi by 2? Minus 1. So from here can you write x or pi by 2 is equal to minus x of minus pi by 2, right? So from here the same thing comes out that x of t equal to minus x of t. So hope you understand these two types of signal, even and odd signals. Now next classification is energy and power signal. From the term energy and power, we can easily determine that we are talking about the strength of signal. So what are the conditions for a signal to be energy type or power type? This we will be talking about under this classification. First is energy signal, and this is how energy of a signal is given from minus infinity to infinity x square t of dt, where xt is the signal. Now what are energy signal? Which has finite energy and zero average power. This means that energy whose value must lie between 0 to infinity and its power must be 0. For a signal to be either energy or power signal, the one has to be finite and other has to be either 0 or infinity. So in case of energy signal, its energy of energy signal must be finite and its average power must be 0. Now it says that example of energy signal are aperiodic signal. Means those signals which are aperiodic will be energy signals. Why are we saying this? Let us consider one aperiodic type of signal. Say E of minus t, right? So can you see that this signal is getting vanished at some point of time? So this means if we try to calculate its energy, it will be finite because this signal is finite. Finite signal has finite energy, but when we calculate its power, so it will be 0. So this means this type of signal is energy signal. So this is the power signal. This is how we represent power of a signal. Power of a power signal has finite value and it has infinite energy. This means its value is between from 0 to infinity, that is some finite value, and its energy is infinite. Now example of power signal are periodic signal. So now why we are saying this periodic signal? So let us take example of again sine wave. We know that sine wave flows like this and it goes like that to infinity. Can you find its energy? Of course not. Why? Because its energy will have some infinite value which cannot be determined because it is infinite. So such signals whose energy cannot be calculated because it has some infinite value, we go for its power. So power of such signal is finite. So that's why we are saying that power signals are those which are periodic. Whenever a signal is given, if it is periodic, then you need to calculate its power, and if it is aperiodic, then you need to go for its energy. Okay, so these two type of energy and power, these two terms, they basically define the strength of a signal. So either we can calculate the strength through energy or through power, depending on the type of signal it is. So hope you understand all these types of classification, four types, like two I have already talked in my previous video and two in this video. So if you are clear with it, then it's okay. But if you have any doubt, please do ask. So please like and share, and do subscribe my channel if you haven't subscribed it yet. So thank you. Bye everyone. Take care.